So hello everyone, today I will explain how to calculate the combustion efficiency in a Scramjet combustor after the simulation is completed. So here is the simulation file which I have opened, and in the ANSYS FLUENT this is the solution interface. In order to calculate the combustion efficiency, this is the formula for combustion efficiency. We can see for combustion efficiency what is the data required here, like this is the combustion efficiency which is given by 1 minus integral A density into velocity into mass fraction of H2 into dA, means area, divided by mH2 inlet. mH2 inlet what it is? Mass flow rate of the injected fuel. Okay? Either we will use this formula or we can use directly this formula. Okay, so instead of what I will be using, I'll be using this formula, but instead of mass flow rate I'll be using mass fraction like YH2. Okay, I'll be using mass 1 minus mass fraction of hydrogen divided by mass fraction of the hydrogen inlet. Okay, this formula I will be using for calculating the combustion efficiency. Okay, or if we want to go with this formula, so we need to calculate density, velocity, mass fraction, area, and ms2 inlet, all these, multiply all these terms, integrate it, and then divided by mass fraction, mass flow rate of hydrogen inlet, and 1 minus this one, so it will give the combustion efficiency. So what I will be using, like I will be using this one. So we'll come to our simulation interface, and for calculating the solution, for calculating the efficiency, the whatever the certain kind of data which is required here, already I have made the combustion efficiency graph. Again I will calculate this. For this I will make one new Excel sheet, new Excel, and here I will mention the position at different what are the position at which I want to write the data. So here will be the x, it will be in meter, so x in meter, and here I will be writing what are the data required here. X, like at what position, all the values I will be finding, then x along with the density, speed. Here I can see what we need: density, speed, mass fraction, area, and mass flow rate inlet. Okay, 5 things. Okay, so I will be writing these values. So in order to calculate these values, I will be finding these values at each and every point, and after finding at each and every point I will calculate the result. So let's say for after x I will take the data of density whose unit is kg per meter cube, kg per meter cube, kg per meter cube. Okay, now next, after density I will take the data of velocity, unit meter per second. Okay, now next, after velocity, mass fraction of hydrogen I will note down, mass fraction of hydrogen, H2, hydrogen. So mass fraction of hydrogen. Okay, because since we are using hydrogen oxygen combustor, like hydrogen is used as a fuel in our combustor in our case. So I'm taking the mass fraction of hydrogen. Here I will be taking the value of area, whose unit will be meter square, not meter per meter square it will be. Okay, now next value will be mass fraction of the H2 hydrogen inlet. Mass fraction of hydrogen inlet, mass fraction of H2, in bracket I will write it like this is the inlet mass fraction. Okay, so mass fraction, now mass fraction I noted down, and after that here I will write the efficiency, combustion efficiency. Okay, combustion efficiency. Okay, in percentage. Okay, combustion efficiency in percentage. After that, now I will note down the value at different points. Let's say I will take the point as 50 mm, next 80 mm, next 100 mm. Here our length of the combustor is 300 mm, so I'm taking some random 8 points and I will note down the value and I will calculate the combustion efficiency. Okay, so 100 mm, then after that I will take 130 mm. Okay, after 130 mm, 150 mm, then 190 mm, then 210 mm, and then 300 mm. These are the values of X, and I will note down the different values of density, velocity, mass fraction of hydrogen, area, and mass fraction of the hydrogen inlet and combustion efficiency from the fluent, ANSYS fluent. So for that I will open my file first. I will open the exact file in which I want to extract the data. So I'll open my ANSYS fluent file in order to calculate those values, and I will draw the graph of the combustion efficiency in the Excel sheet. We'll wait until it's open. Click on unlock, click on yes. So here it is loading the file. Okay, right click on solution. Already I have run the simulation. Right click on the solution, it will load the ANSYS fluent solver, and from there I will extract the different values by making different lines, lines in transverse direction at 80 mm, 30 mm, 130 mm, 210 mm like this, and I will extract the values. After making the lines, I will extract the values. So once it will get loaded, then I will extract the values. It is loading the data. We'll wait until it's get load. So here is our combustor. So I think already I have made some lines in transverse direction at different x distance. So go to surface, click on this plus icon. Already I have made this line 80 mm, 100 mm, all lines are there. What are the lines I have made here? 8, 50, 80, 100, 130 like this. Okay, So I think 50 is not there in this, so I will show how to make one line. I'll create one line 50 mm, click on new, right click on the surface, go to new, go to line and rake, then click, write the 50 mm line I am making. So 50 mm in meter, how much it will be? 0.05, and y value will we will write from -1 to 1, 5 and -1 to 1. I'm writing -1 to 1 because it will cover the full range. Like our combustor is this much 50 mm. The height of the combustor is 50 mm. So if I am writing -1 meter to 1 meter means it will be a very long distance. So it will automatically cover the this combustor y distance, whatever it is height, and x value I have written as 50 mm. So our my axis is here in the center. So it will go at 50 mm here somewhere, 50 mm, and it will make a vertical line at 50 mm covering from here to here. This one. Now click on create. So 50 mm line will be get created. So I think all points are there like this. Similarly, we'll make different line at different distances. Already I made already just now I made 50 mm, 80 mm is also there, 100 mm. What are the data required? 100 mm, 130, 150, 190, 210 and 230. Okay, and 300. Okay, so 100 is there, 130 is there, 150 is there, 190 is also there, 210 is also there, 300 is also there. So, okay, now I will calculate the different values at different point. So in order to get the values at different the average value at different sections in the transverse direction, go to report. Here is a symbol called report. Click on this plus, then double click on surface integral. Then in order to calculate the what is the first required value, first we need density value. So from here from the report type, change to area weighted average, and from field variable choose density, and at line 50 mm choose line 50 mm. Here is the line 50 mm, choose this one and click on compute. So it will give the average density value here, average area weighted average kg per meter cube, which is the unit of the density. Means it is giving the area weighted area with respect to area, it is giving the average density value at 50 mm. So I will note down this value. I will in my Excel sheet, either I can select and copy from here and paste it here, or either I can select, either I will select here from paste, or either I can select from here also. In this box also we can see the values is there. From this box also I can select, control C, and then we can paste it in the Excel sheet. Okay, so next, velocity I required at 50 mm. So I will choose from here velocity magnitude, velocity field variable velocity magnitude, and click on compute. It will give the velocity value. Now I will copy this one, control C. After selecting control C, copy this velocity here. Okay, now mass fraction of hydrogen. So in order to calculate mass fraction of hydrogen from field variable, again coming to ANSYS FLUENT, choose species, mass fraction of hydrogen. If it is not coming mass fraction of hydrogen, then choose from here mass fraction of hydrogen at line 50 mm. Press on, click on compute. It will give the mass fraction of hydrogen. Again we can select this one, press Ctrl C, and again we can paste this value in the Excel sheet. Okay, now for calculating the area at the 50 mm, again go to ANSYS FLUENT. In order to calculate the area, change this report type, click on area, select area, line 50 mm is already selected, click on compute. So it is giving the average value of the area. Select this value, Control C, and paste it here in the Excel sheet. Again go to mass fraction of hydrogen inlet. In order to calculate the mass fraction of the hydrogen inlet, since this is our inlet phase, this phase and this phase is our inlet phase. So in order to calculate the inlet value from this phase and this phase, like from this edge, we can select directly fuel inlet part here, deselect this one, remove the selected line 50 mm, and click on fuel inlet. It is asking, right, mass fraction of hydrogen at inlet. Okay, so hydrogen at inlet means from fuel injector how much mass fraction is coming out, that one we will calculate. Okay, mass fraction of the hydrogen at the inlet. So select this one, fuel injector. Now select area weighted average from report type, and from fuel injector how much mass fraction of hydrogen is coming out. This one will, it will get calculated, it will get displayed. So we will select fuel injector and species, mass fraction of hydrogen, press on compute. So this is the mass fraction of hydrogen from the fuel injector. Select this value, press Ctrl C and paste it here. Okay. Now in order to calculate the combustion efficiency, what formula we will be using? We will be using 1 minus this one, 1 minus ys2, 1 minus, already I wrote here, 1 minus YH2 divided by YH2 inlet, YH2 inlets. Okay. So what is this YH2 and what is this YH2 inlet? YH2 is the mass fraction of the hydrogen at different x distance, and YH2 inlet is the mass fraction of hydrogen at the inlet section, like at the fuel injector. Okay. So I will note down all this value. So already I have extracted this value here. Okay. So for writing the combustion efficiency, I will write it here, 1 minus mass fraction of the hydrogen divided by mass fraction of the hydrogen at inlet. So it means mass fraction of the hydrogen, this one, divided by mass fraction of the hydrogen inlet, means 1 minus d2 by f2. So select this combustion efficiency block, press control, sorry, not control, equal to 1 minus d2 by f2. Either we can take one bracket and write d2 by f2 and bracket close, then it will automatically get selected this d2 and f2, means d2 by f2. Here we can see this blue color is showing this blue color, and this f2 which is in red color is showing this f2. And after closing the bracket, press enter. So it is giving the value of the efficiency. Okay, it is giving the value of the efficiency what we are getting from here. Okay. So for at 80 mm, like this only, at 80 mm I will calculate the values. Mass fraction of the hydrogen, area weighted average, this one. Okay. One more thing, like combustion efficiency, for one more thing I need to tell you, like for since the fuel is injecting from the length of the combustor is 300 mm and fuel is injecting from length 67, this part is 67, like here is our fuel injector at a distance 67 something around. So since we have taken the line 50 mm, it means the hydrogen which is here is zero, like negligible. Here we can see the value. Here we can see the value hydrogen which is available at 50 mm is very less, like not negligible also, like it is zero only, like 8.65 into 10 to the power minus 18, like nothing is there, like very like very less value, no hydrogen is available here. So that's why combustion efficiency is coming 1, means since 1 minus ms2 divided by ms2 inlet, it means like no hydrogen is there, so it came 1. So what we will do, we will not uh, use this value 50 mm, we will select those points or those lines which is just after this combustor, because we are calculating combustion efficiency. So for calculating the combustion efficiency, we need hydrogen and oxygen to get combustion. Okay, since here no hydrogen is there, so no combustion is happening, so combustion efficiency is coming 1, means nothing is like no combustion happens. Okay, because no hydrogen was there, only inlet was also not there. So we will choose line 80 mm and then we will calculate the value. So I will select the line 80 mm, and now fastly I will calculate all the values. Density value at line 80 mm, select it, press compute, Control C, then select write the value here, density value. Now velocity, press compute 490, Control C, paste it. Again, mass fraction of the hydrogen, mass fraction of, already species mass fraction of hydrogen is selected. Press on compute, copy this value, go to Excel, copy this value. Next, area is required at 80 mm. From area weighted average, select area, press on compute. This will give the area value. Control C, press compute, Control V. Again, mass fraction of the H2 inlet. Since mass fraction of H2 inlet is constant, like fuel injector, from fuel injector, whatever mass fraction is coming, that is constant. So we will get the same value again and again, 0.9999. Like it is around 1 only. So it will be same for all. Okay. So we can try, press here. If we bring to the corner, down corner, we can see the plus icon is coming here. Once the plus icon start coming, thin plus icon, this is thick one. Once the this thin black color, not hollow one, this filled one plus is started coming, press here, right and left click on the mouse button, press and then pull this one up to where we required. We required up to 300 mm and then leave it. So it will give the same value. Long means 0.99 means around 1 only, because mass fraction of the hydrogen which we are giving from the inlet, it is 1, like complete 1 mass fraction is coming. So at 100 mm, I will delete this because at line 50 mm no combustion is happening. So this one is not required. Okay, I will delete this one. So now at 100 mm, I will calculate the density value. It is 1 point something. I will just copy it here. Again, velocity value, velocity magnitude, Control C. Again, mass fraction of the hydrogen, so go to species, mass fraction of the hydrogen at 80 mm, Control C, Control V. Now area at 100 mm, select area, get the value, Control C, area. So this one will be this one, the formula will be is equal to 1 minus, in bracket we can select this one. If you select this one, so automatically d3 will come. Like no need to see whether it is d3 or d4 or d5. Just select this one, so automatically it will take this value and it will write here d3 divided by ms2 divided by ms2 inlet. So this one, ms2 inlet, select this one, automatically it will write f3. Now close the bracket, press enter, it will give the value. Okay, now let's say for this case already I noted down the value. If I want to calculate just this cursor, we can see plus cursor, some hollow part is there. Once we will bring to this here at the corner, down corner, in the right hand side corner down, we can see this hollow plus cursor will become solid one in thin one. Then press right click and left click, not right click, press left click and pull it up to here, up to where we have noted down the value. We have noted down the value, we have noted down the value up to 100 mm. So press up to 100 mm and then leave it. Then it will give the value at 100 mm what is the combustion efficiency. It will use the same formula, 1 minus d2 by d4 by f4, like this. If for each and every case it will. So again for 130 mm, so for 130 mm we will calculate the value. We will paste it here like this only, like this. We will paste it each and every value like this. We will calculate all and each and every value. Then for velocity, similarly we have to calculate all these values. 0.056, this one not, wait, at line 130 mm, at line 130 mm, what is the value? 130 mm density value, Control C, paste it here. So like this we will note down all the values, velocity values also we will note down. And after noting down all the values, we will calculate the combustion efficiency as we have done for 80 mm and 100 mm. Like this I will note down, and instead of like writing again and again, already I have noted down these values here. Okay, okay. So what I will do, This one combustion efficiency already I made 2 point. So this was the position along center line. This is, I think. Okay, okay, correct, correct. So what I will do already is I'm deleting this data, this graph, and showing the, see, like this. Similarly, we have to note down all the values as we did for 80 mm, as we did for 80 mm and 100 mm. Like this, we will note down all the values. Already, I have noted down here in the Excel sheet. Now I will, what I will do, I will draw the graph of the combustion efficiency versus its distance. So I will select this. I will press left click, left button on the mouse, pull this one up to down and select this one, press control, select this one, pull down, and then go to insert, click on this chart, insert scatter, click on this, choose this one, line one, and here we can see the graph is came, the combustion efficiency graph came. I want to write the chart title as, click on this, press control A, cut this one, then write combustion efficiency, efficiency combustion efficiency. Okay, combustion efficiency. Okay, combustion efficiency. And in order, if I want to give a axis title, press on this plus button, tick mark this axis title, and we will write this as combustion rate, combustion efficiency, combustion effi combustion efficiency, and this is our x, x in meter, x in meter. Okay, and here instead of combustion efficiency I will write as combustion efficiency along center line, along center line, combustion efficiency along center line. So our length of the combustion is 100 mm, sorry, 300 mm. So from 0 combustion will start from 67 something. So I have started the value from 80 mm. So we can see like from how from 80 mm combustion initially increases and little decreases there and then again it started increasing and combustion efficiency become 1 something. Okay, so this was the combustion efficiency plot, how to draw the combustion efficiency plot. This was the graph. Okay, from ANSYS FLUENT, how to extract the data and how to make a combustion efficiency. This one we came to know through this. Okay, how to draw. Now in the next video we will see how to draw the mixing efficiency plot and total pressure loss. Okay, for this much, thank you.